making formulas using variable oxidation state metals. Variable oxidation state metals include these transition metals, and the problem with the transition metals is they can have more than one charge, and the fancy name for that is oxidation state. These are some common charges. You'll notice that in group 1 and group 2, the charge matches the group number, and in group 3, aluminum's charge matches the group number. Silver, cadmium, and zinc have only one charge, and they will not follow what we're going to be doing today. But in naming compounds that involve transition metals, other than zinc, cadmium, and silver, you need to use the charge to tell what charge is being used to make this compound. So for example, when we say gold 3 bromide, the 3 represents gold at a +3 charge. So in making this formula, I would take gold at +3, and then bromium over here, the bromide ion in group 7 is -1. And when I put those together, I get AuBr3. With iron 2 chloride, I know that iron is +2. Chloride again is in group 7, it's -1. So I'll need iron and 2 chlorides. Whereas iron +3 chloride will need iron with 3 chlorides. So when you see Roman numerals, you need to remember that they are telling you what the charge of the ion is. And notice it is not giving you the subscript on that metal. It is giving you the charge, and you'll use that to determine the subscripts that you need, or the ratio you need for the compound. Also, when you see a compound that involves transition metals, chromium here and manganese, you can often work backwards to figure out what the charge is of that chromium. For example, if I have chromium 2 and then 3 oxide ions, I know that oxygen is -2 because it's in group 6. So if I multiply the number of oxygens times the charge, I have 6 negative charges. Well, this is a neutral compound. There's no charge in that when we started. This is a neutral compound, so I also need to have 6 positive charges. So if I now divide 2 into the 6, I have chromium, and chromium is +3. So the proper name for this compound is chromium 3 oxide. On the other hand, here's manganese with 4 oxygens, and this is going to be a little bit crazy, and I probably shouldn't have done this, but I have. So we'll just name this the way it comes out. Oxygen would be -2. I would have 8 negatives. The manganese has to have a +8 charge. So it would be manganese 8 oxide. And whether that one's right or not, I think actually this is probably the one that I wanted. And this would be manganese 4 oxide. So that's what you're going to do with the transition metals. They're going to work a little bit differently, and the little bit differently part will be when you name them, you need to use